Hello friends, today we are going to discuss about thyristor and its gate characteristics. So friends, as discussed earlier about the mode of operation of thyristor, today we are going to discuss about how the gate is triggered in a thyristor circuit, or how we can give a gate pulse to a thyristor circuit. So friends, remember one thing, always a pulse signal is applied to the gate terminal of a thyristor. But there is a problem in that. Whenever we supply a gate pulse to a thyristor, the thyristor starts conducting. If we withdraw the gate pulse from the gate terminal of the thyristor, it does not stop the flow of electric current through it. It still continues the flow of electric current through it. So thyristor is a device which allows the flow of electric current whenever there is a gate supply. But if we withdraw the signal, it does not stop conducting. So we will be discussing in detail about all these phenomena in this chapter. So friend, if you can see this electrical circuit, so here there is a thyristor, which A is the anode, K is the cathode, and G be the gate terminal. So in this circuit, the thyristor is connected, say a supply voltage, which I have not drawn here because I wanted to show you the gate operation of the thyristor. Now here, I'm connecting an ES supply, which is connected across the gate terminal and the cathode. So the ES supply is connected through an internal resistance, say RS with a series internal resistance with the gate terminal. So now let VG be the gate voltage, which is induced in the gate terminal with reference to ground or cathode. So friends, let's talk about how does a firing pulse look like, or what do you mean by firing of a thyristor? So in simple words, firing of a thyristor is defined as whenever you give a signal to the gate terminal of the thyristor so that it allows the flow of electric current through it. Normally, the firing is through a pulse, and the angle at which the firing is implied or the firing is applied to the thyristor gate terminal is called the firing angle, which is denoted by alpha. So friends, here I try to explain it to you in a very simple way. Let's see Vs be the source voltage or the voltage across the thyristor terminal. Let's say we are applying a sine wave across the thyristor terminal with Vm be the maximum amplitude of the sine wave. And the equation of sine wave be Vm sine omega t. So here, let x-axis be the time omega t axis and y-axis be the voltage axis. Now, here, let's say here, at a time interval which is alpha, which you can clearly see here, we started applying a firing pulse. Now what happens? The thyristor in the circuit starts conducting. So what happens is that the thyristor starts conducting because we are applying a triggering pulse or a gate pulse after a time interval which is alpha. Now friends, let's see how does the conduction voltage or the conduction current look like in this diagram. Here, if you can see in the third waveform, here at a terminal alpha, the thyristor starts conducting, and here you can clearly see there is no conduction from 0 to alpha, but the conduction started after alpha to an angle pi. But after pi to 2 pi, there is no waveform because thyristor never allows a bidirectional flow of electric current. Like diode, thyristor allows the flow of electric current only in one direction. So friends, again, after a time interval 2 pi plus alpha, the thyristor again starts conducting. Again, it eliminates the negative waveform Again, after a time period of 4 pi plus alpha, again the thyristor starts conducting. So if we see the fourth waveform, which is the waveform of electric current, here the electric current follows the same waveform as the voltage. So here at a time interval of alpha, the current starts conducting. Again, the thyristor does not allow the bidirectional flow of electric current. So the negative waveform here, it got eliminated. Again, after a time period of 2 pi plus alpha, again it started conducting, and so on and so forth. Now friends, let's talk about in detail gate characteristics of a thyristor. So if you all can see this diagram, so when you work with a thyristor, this diagram in the data sheet is extremely important. So here, what you can see is, let Ig min be the minimum current, let Vg min be the minimum voltage, let maximum average gate power dissipation limit be PGAV, let the gate current limit be Ig max, which is the maximum gate current limit, and the maximum gate voltage limit be Vg max. Now friends, if I draw a graph to show you the gate characteristics, let's say this axis, the x-axis be the gate current and the y-axis be the gate voltage. Now, here friends, you can see curve 1, this be curve 2, and this be curve 3. Now, curve 1 and curve 2, if we talk about curve 1 and curve 2, what we can see is curve 1 shows that the minimum gate current and the minimum gate voltage that should be applied to the thyristor, so that after that threshold, the thyristor starts conducting, or the thyristor starts allowing the flow of electric current through it. The curve 2 shows us the maximum gate current and the maximum gate voltage that can be applied across the gate terminal of a thyristor, so that the thyristor does not get damaged. Now, you can see VNG here. Let VNG be the non-triggering gate voltage. That is the maximum gate voltage after which the thyristor starts conducting. And Vg min, you can see here, Vg min is the minimum gate voltage that must be applied across the gate terminal of a thyristor, so that the thyristor starts conducting electric current. So here we have a safe operating region. If we see this curve, there is a curve 3 which is called the operating curve, or in this curve, or the curve which lies between the minimum curve, which is 1, and the maximum rated curve, which is curve 2, those curves which lies between these two are called the safe operating curves. Or in other words, if a thyristor operates in this region, which is in between curve 1 and curve 2, this is said to be the thyristor is operating in a safe mode. So here you can see S1 is a mode, S is the second mode, and S2 is the third mode. So here we can say S1 is the minimum requirement for the thyristor to start conducting the electric current, and S2 is the maximum requirement of the thyristor current, or the maximum limit of the thyristor gate voltage and current requirement, and S be the mode of operation of thyristor. So here in this mode, S can lie anywhere above S1 but below S2. That is called a safe mode of operation of a thyristor. Thank you for watching this video, friends. Please subscribe to Ekeeda. Thank you so much.